Moving onward to our next guest speaker today. Title of his presentation is Building the Privacy and Security Layer for Web3 with Zero Knowledge. I'd like to warmly introduce to you all fellow Jersey guy and COO of the Mina Foundation, Kurt Hemecker.
Thank you, thank you. So before I begin, I would just like to thank the organizers of this event, D-Data Studios, as well as the title sponsors, Kylan Networks, NFT3, and Ruby, for the opportunity to present, as well as Adam English, and I suggest you guys check out his podcast, Crypto with English, for learning lots of good things about the market. And most of all, I'd like to thank all of you for being here, particularly after lunch. So while you're digesting your lunch, hopefully I can help you also digest some more information on zero-knowledge proofs and how it can be used for scaling the privacy and security layers for Web3. So as mentioned, my name is Kurt Hammacher, and I am the Chief Operating Officer of the Mina Foundation. And the Mina Foundation is serving the Mina Protocol, which is well known notably as a lightweight layer 1 blockchain built on a native deployment of zero-knowledge proofs. The Mina Protocol was incubated by O1 Labs, and its mainnet was launched in 2021. And a big shout out to my colleague, Phil Kelly from O1 Labs, who literally just got off of a very long plane ride, but joining us here. So hopefully you have a chance to speak with us during some of the breaks. And today I'll be talking how zero-knowledge proofs can be used for scaling security and privacy within a Web3 framework. And before I begin, I thought it'd be interesting to ask a question. Actually, let's do it this way. I'd like you to raise your hand if your data, if you've never been breached or hacked from your personal data. So in other words, if you've never ever received an email or a notification that your data might have been part of a breach or you've been hacked, only if that's never happened to you, raise your hand. Not many hands going up. I see one, so congratulations for safeguarding your data. Chances are it might have been breached and you might not have known about it, but hopefully not. And for those of you who didn't raise your hand, I'm sorry about that, but you're in good company. According to Statista.com, just in the second quarter of this year alone, internet users worldwide were subject to over 52 million data breaches. So despite the improvements in security and encryption, this is a recurring problem, and until we change how users are able to interact with the web and interact with their private data on the web, it's going to continue happening. And here at Mina, we certainly believe, and this was discussed on the last panel, about how do we decentralize the control of that data and give users the control and the power of deciding what they want to share and who they want to share it with. And of course, this is very, very important because we're talking about privacy. And just a few quick words on privacy. It's a fundamental human right. It's actually enshrined within the UN Declaration of Human Rights. And in Web3, as I think all of us here are aware, we define privacy as the ability to decide what you want to share and who you want to share it with. And typically, this is some combination of pieces of your identity and your actions. And we all know that Web 2 is defined as centralized platforms controlling user data. And this transition from Web 2 to Web 3 is representative of the evolution of the decentralization of that control and giving that power and the control of their own data to the end users. So the question is, how do we get to Web 3? What do we need to do? Well, we get there by developers creating applications, decentralized applications that again can hand this power off to the end users. And zero-knowledge proofs are one important technology, one of many important technologies that developers can use to, again, enable users to decide what they want to share, who they want to share it with in a decentralized environment. And up until now, probably zero-knowledge proofs were better known for scalability and roll-ups, particularly within the Ethereum environment. But now they're becoming just as well known for programmable privacy and security. There's probably varying degrees of familiarity with zero-knowledge proofs in the audience, but maybe just a quick primer for those who aren't familiar with it. It's actually a deeply complex cryptographic technique, but at the very high level within a zero-knowledge proof transaction, there's principally two parties, a prover and a verifier. And the prover wants to prove that something is true without exposing sensitive data to a verifier who's going to verify that yes, this data can be attested to. And so concretely, what does that mean? It means things like being able to show that you're over 18 or 21, over the legal age, without giving your date of birth or your birth date. So that's the power of it. And there was a lot of interesting discussions earlier on today from a lot of the identity providers. So I think there's a very strong marriage between identity providers and zero-knowledge proofs, because you can then control, users can control what parts of that identity that they do want to share and with whom. And there's many, many use cases, potential use cases for zero-knowledge proofs across finance, health, media, news, gaming, and of course, natively within Web3. And I'll talk about a couple of these use cases now. One of these use cases is private Dow voting. And one of the challenges here is if votes are not private, if other members can see how other members are voting, this can lead to biased influences. So people might not vote the way they had been intending to vote. Or if you see that your side is winning or losing by a lot, it could have the undesired impact of leading to voter apathy. So with zero-knowledge proofs, votes can be conducted securely and privately by members of the DAO without exposing individual votes to the rest of the DAO, and then just the results of the vote can be displayed. And this is actually a great interoperable use case for a chain like Mina. A DAO developer can create an account on Mina. Their members can vote privately and securely on Mina. The results of the vote can be updated through a bridge onto the main chain of the DAO. And then the DAO developer can use a smart contract to obtain the results of that vote. Just another example is certainly completely within DeFi, zero-knowledge proofs have a place, but in thinking about how can you combine real-world or traditional finance data with DeFi, particularly DeFi lending. And as many of you know, most, if not all, DeFi lending is based on over-collateralization. So meaning borrowers need to have more crypto assets than they're looking to borrow. And that kind of defeats the purpose of borrowing in some extent, and definitely limits the market or inhibits it a bit. And traditional finance certainly doesn't work that way. So if you could allow, for example, with zero-knowledge proofs, the possibility for borrowers to demonstrate their creditworthiness and their credentials by pulling in some information from traditional finance, from their bank account, for example. And you could also combine that with information about their crypto assets to show creditworthiness, but again, without exposing any sensitive data to the lender. So in that way, their information is protected, and the lender can still, abide by their collateralization risk rules. And then the third one, which I'll just briefly touch on, is the safe interoperability of private enterprise data with public smart contracts. And again, I think many of us in this room are confronting this challenge, is like, how do we how do we bring blockchain to the masses? And one of those, if we can unlock the ability for companies to start using it more, that would certainly help. And one of the main reasons why they don't is because they don't want to expose sensitive information publicly, sometimes for competitive reasons, sometimes for compliance and legal reasons. And if you think about a supply chain construct where you have multiple suppliers, manufacturers, logistic providers, using a public blockchain could have many benefits rather than each of these organizations trying to run their own networks. However, again, nobody would want any of their sensitive business information to be known by competitors. Just think about that for a minute. For example, here in Germany, there's very well-known manufacturers of trucks that obtain enormous amounts of telemetry data about the transport of their vehicles. How valuable is that information? And they actually sell that information, but they go through several different intermediaries, and nobody knows really what happens to that data. So, should the sleeping heart rate of the truck driver data be out there somewhere on the market? No, it shouldn't be. So, again, using zero-knowledge proofs, this information can be protected so that sensitive information is not disclosed. So what does Mina bring to the table? And I'll quickly talk about first the protocol layer of the Mina Protocol and then the smart contract layer. So a couple of important points. One is no bloating. Because of its native deployment using zero-knowledge proofs, regardless of how many blocks get created, regardless of how much time goes on, the state of the blockchain can be read in one constant size. And currently that's less than 22 kilobytes. And that makes it perfect for cross-chain interoperability, for example, because that small size, you can keep the state of the Mina blockchain on-chain in a smart contract in another chain, like with Ethereum. And we've currently co-funded a bridge with the Ethereum Foundation that allows that to be done. Again, that small size allows efficient verification. Complex computations can be done off-chain, but again, verified in that small state on-chain, which makes it very low cost, 0 to no gas fees and very low transaction fees. And again, that leads to it being scalable and trustless. And one of the advantages there is that participants can get the benefit of being directly on the blockchain. They don't need to go through an intermediary like to get to a full node or the benefits of that. So they don't need any other third parties in the way. They get the full benefit. And that's even from a web or a mobile environment. And the last thing, it's been built to scale with decentralization in mind. And as we know, with more decentralization comes more security. On the smart contract layer, this consists of a novel ZK snark-powered smart contract layer that we call ZK apps. And our partner, O1 Labs, who again incubated the Mina Protocol, they've launched in June of this year Snarky.js, which is a framework for building ZK apps. And it's accessible to developers, Web2, Web3 developers, who don't need to have a PhD in cryptography to use it, using a well-known programming language in Web2, TypeScript libraries. And with that, they have the ability to create routines with infinite recursion. And that means an unlimited number of transactions can be rolled up into a constant state proof. And that can further be optimized using custom gates and WebAssembly language or WASM. And today you can store and verify proofs on the Mina testnet. And we're working very diligently to roll out an incentivized testnet for ZK apps where developers can work on building and playing around with ZK apps, which leads me in for the grand finale. If you are a developer or you have developers in your organization and you'd like them to start playing around with zero-knowledge applications, if you scan this QR code on the right, you can be led to a registration page to have the opportunity to earn grants for helping us with the testnet. And in addition, if you go to O1 Labs GitHub or docs.minaprotocol.com, developers can get more information there. And if you just want to follow the conversation, visit us at minaprotocol.com or follow us on Twitter at Mina Protocol. And again, thank you so much for your attention after lunch. I really appreciate it.
Excellent presentation, Kurt. And by the way, thank you for the shout out for my show as well. Appreciate that. That's right. Now moving on to our Q&A portion. Are there any questions, comments, musings for Kurt and his project? Going once.
I answered everything. Excellent.
Yeah, I was going to say, yeah. Well,
all right.
I guess we're good then.
All right.
Thank you very much, Kurt. Great job.
So